our Chapter 5 video recording of measurement concepts. When we talk about measurement concepts, what we're really talking about is the various surveys, assessments, measures that you will select to use that are going to be able to measure your independent variable and your dependent variables. So for instance, when we did our information processing study in our class, we were trying to look at the difference between shallow processors and deep processors as it related to word memory recall. And so we used a couple of different measurements in that particular study, right? So one way that we measured the conditions of shallow or deep processors was the instructions that you were given. And so we measured sort of by instructions the independent variable through these instructions that asked you to do one of two things depending on which group or condition you were in, shallow or deep processors. We also were able trying to measure dependent variable word memory recall based on asking you how many words can you remember from what you just saw on screen. And so that's what we mean by measurement concepts, is just different ideas and ways of understanding how we use measurements, what's important about measurements, and how we even make decisions about selecting measurements. So moving right along, the first thing that we have to be concerned about is the reliability of measures. So whatever measures and assessments that you're using, you always want to make sure that your measures are reliable. A measure is reliable when it has a certain level of consistency or stability. In other words, that a person can take the measure again and again and again, it doesn't matter how many times, and they're going to have a relatively same or stable score over time, so that the scores are consistent, and that's reliability. Now, we're also concerned about the observed scores. This is what we're really interested in here. But we do know that measures provide us with something called true scores. A true score is an actual score of the variable being measured. And we also call that true ability. And here we have to be cautionary about these true scores and true ability, because even though when we ask someone to take a measure or to answer a survey questions or do some type of an assessment, we think we're picking up their true ability, but in fact we're not. So this is why we have to be cautious about how we understand the scores that we're getting, and what we even call the scores. We know that this random error does exist, and in fact, we statistically resolve that using our standard error of measurement in many of our test statistics. So you need to understand that a person's true ability or true score on a measure or an assessment also includes something called random error. And that random error comes from the conditions by which the person is taking the measure. Maybe how they felt that morning, or maybe they've seen something similar like this again, or maybe they just weren't really paying attention. There's a lot of conditions and things that are occurring in a person's life that causes that random error. And so therefore, we don't really call it a true score like we have here. What we do call that is an observed score. So you might hear me reference that like, oh, did you get your participants' observed scores? Or make sure that you clean up the data of the observed scores, because I'm just telling you that, yes, these are the scores that you receive from your participants, but after we run our statistics, we know that we're taking into consideration this random error that happens to occur every single time a person takes a test, assessment, or a survey. Now let's talk about that idea about reliability a little bit more. So reliability, again, is when a person has consistency or stability of a measure of a behavior. So we want to make sure the assessments that we're using are consistent and stable and therefore are reliable. Now this is a really nice indicator of a reliable measure. We can see that all the scores of these observed scores or scores obtained kind of fit really nicely, right just around the score of 100, a little bit below and a little bit above, maybe 10 points below and above the score of 100. Now, what would be an unreliable measure is something that has a much wider range, because we have scores that are going a little bit as high as 115, as low ends of towards 85, with a lot of scores somewhat here in the middle, but then a smattering scores here and a smattering of scores there. Now we're concerned about that because that's where we have, again, that measurement of error. And you know what? IQ tests are unreliable measures. We know that. Psychologists understand it. We know, or at least we think we know what intelligence is, and we think we understand some of the best ways to measure intelligence, but we're not getting these clean, reliable measured scores. We're actually getting a whole range of scores, and it is a normal curve and it's a normal distribution, but we're still getting these range of scores, and we have some concerns about IQ tests. And in fact, the state of California does not allow any school districts to use IQ tests to measure children's abilities of intelligence. Schools have to use some other assessments and measures to identify ability and not intelligence because of the unreliability of this particular measure. So we always have to know that the scores we obtain, especially on something like this, are these observed scores and always have a measure of error. But again, reliable scores that fall into a plane like this, these are great. That's what we're interested in finding. Now, how do we even measure reliability? What do we do with that? Well, our goal to measure reliability is to make sure that some type of an assessment or survey has something called internal consistency. Internal consistency means that we've employed certain statistics, typically different types of correlations, that assess the reliability of the measure. So when we have internal consistency, that means we've achieved some type of a minimum number that shows us that these measures and the scores within these measures are correlated well within each other. And there's different ways that we can do that. So let's look at each one of these. So we have retest reliability, where we have the same individual take a test at 2 different points in time. So they have test at time 1 and then the same measure at time 2, and then we correlate time 1 and time 2 scores together and hope that we have a good correlation there as well. Now, retest reliability has some issues. It's vulnerable to artificiality and maturation. Artificiality is really when we're not really assessing the person for like maybe their stress levels or their anxiety levels. We're really just assessing to see whether or not we're going to get this reliable score at time 1 and time 2. So it's kind of artificial in that we're just interested in the score itself to see if there's a good correlation, but not necessarily about the actual person's kind of lived experiences. We also have something called maturation effects that is problematic, and that means that once a person takes the test more than once, they've matured through the test. In other words, they've already been exposed to the test, and we don't know if the scores at time 2 are really accurate because they've already been exposed to that measure, maturation. Another thing we do for correlations is split half reliability. We take a correlation of scores of one half of a test with the other half of scores. So we had a measure with maybe 20 questions. We could take the first 10 and get those scores, observed scores, and correlate it with the second half of scores, 11 through 20. So 1 through 10, correlate it through 11 to 20. We can also do this by taking all the odd numbers and correlating with the even numbers, the scores at the first half with the second half. There's a lot of different ways you can do split half reliability. Now, Cronbach's alpha scores are going to be very important. You're going to need to make sure you understand this because you will be reporting this in the method sections of your papers. So a Cronbach's alpha score is nothing more than the average of these split half reliability scores. So let's take a visual of that. So these split half reliability, and here's where we have an example where a researcher is going to correlate the odd numbers of the observed scores with the even observed scores. So we're taking this person, this one individual scores, and we're doing a split half reliability. We're correlating half of the scores with the other half of the person's observed scores, all the odd numbered scores with all the even question scores. Now, correlate Cronbach's alpha is when you do this and you take this score. Again, it's just an average of a group of people who have taken your score. So here we have split half reliability of person 1, split half reliability of person 2 and person 3 and so forth. And Cronbach's alpha score is an average of the split half reliability of each of the people that have taken your measure as you're trying to evaluate the reliability of it. And that's what Cronbach's alpha score is. Again, I mentioned that's going to be very important because in the methods section, when you write up about the measures, you must report the Cronbach's alpha scores, and you need to find those Cronbach alpha scores from the original authors of that particular paper or in that particular assessment. Item total correlations are very simply you correlate each individual item with the overall total of the scores. And then you have something called inter-rater reliability, where you're taking a correlation between an observation of raters. This is a little bit different in that maybe you have 2 people in your research lab that are reading someone's narrative, and someone says, I believe I would give this narrative a 5 on a scale of 1 to 5 for stress. And the person 2 will say, well, I actually read this narrative and I would give it about a 3.5 for stress. So then you correlate those scores together and see if there's some type of consistency between the raters in how they observe that score. So these are the different ways that we look at how to reliably look at the measures. Now, reliability and accuracy measures are important together. So you cannot have reliability alone. You also need to have something called validity. Now, validity is different than reliability. Again, reliability, when we have our results are stable and they're consistent, we have all these test statistics that we can use and different methods that we can use to understand reliability. Validity is something very different. Validity means that the measure or the assessment in the survey is actually measuring what it's intended to measure. It's actually measuring what it's supposed to measure, and it satisfies the overall objectives of your research study. Now, do know that reliability does not automatically indicate validity. So how do we understand that further? So let's look at this here. Now, when we want something to be valid, we want it to just at least hit the target. We know that not everybody's score is going to be a perfect bullseye, but we want it to at least have scores that are a little bit all over the place. We just want to make sure that people are hitting this overall target. And you can see here that this is an example of scores, a set of observed scores right here. They're reliable, they're consistent, they're stable. Everyone's getting around the same score in the same area, but they're not valid because they're not sort of all over the target area. They're sort of clumped into this one area. So we can see this is a reliable measure, but it's not valid. Now looking at this one, we have validity because now we have observed scores that are hitting all over the target. We're not just in one little cluster area. Not everyone's going to be a bullseye, but at least everyone's scores should at least be randomly scattered around sort of this entire target, right? And that's valid, but unfortunately, it's not reliable because the scores are not consistently stable in one area. Now here we have neither reliability or validity. We have a set of scores that are sort of on this upper half of this target, but they're not reliable because, again, these scores are sort of scattered throughout just on the upper portion. So it's neither not reliable nor is it valid. Now here, this is a nice indication of when we have a measure or an assessment that is actually both reliable and valid. We can see that the scores are reliable because all of the scores are hitting in one area, and they're valid too because we actually got the bullseye here. So we got them all on the target, and they're reliable because they're consistently in the same place. And so this is when we have a measure that is both reliable and valid. So measure can be reliable, but it doesn't mean that it's accurately assessing what it's intended to measure, in other words, validity. So how do we make a good decision on selecting a measure? Well, there's 4 different things that you should always pay attention to. Number 1 is reliability and validity. You want to make sure that the test authors of the assessment and measure have identified strong reliability and validity. And again, you do that with Cronbach's alpha scores. We'll talk in a minute just what that means in terms of validity. Money and time invested. Can you access this pretty quickly and easily through psych tests and not spend any money on it? If you find an assessment or measure you want to use and the test developer wants to charge you $100, not a good test, don't use it. You also need to make sure they're user-friendly so that your participants in your study are going to want to be able to be in your study and be willing to take it. And also you need to make sure that you'll be able to understand how to use the results of these particular measures so you can interpret them in the overall outcomes of your study once you employ your test statistics. Now, let's go back to validity because we really need to talk about, well, what does it mean? How do we know when a measure is valid? We know when a measure is reliable because statistics have been executed on those sets of questions by the test or measurement developer. But how do we know they're valid? Well, we know validity is a little bit more based on our analysis, our understanding of these different types of validity. So let's say, for instance, we're interested in a sleep measure. Number one way of looking at the construct, in other words, the assessment or the measure, how do we have construct validity of a measure? Well, we look at face validity. Does the question appear to be about sleep, right? So here's the definition of face validity. The content appears to reflect the construct being measured. Here we want to measure sleep. So is there face validity? Do the questions appear to be about sleep? This survey will ask about sleep. Yes, it appears that these questions are going to be about sleep. And then you're going to evaluate for content validity. Do questions ask about sleep behavior, right? So content validity definition is the content of the measure is linked to this universe of content that helps us to understand and define the construct. So when we're asking about sleep and sleep behavior, a very common question is, how often do you wake up at night? How many hours do you sleep, right? So anytime you ask a question about sleeping or waking patterns, then that's about sleep behavior. We understand universally that that's the content that helps us to define sleep behavior. Sleep behavior, do you wake up at night? Do you sleep all night? How many hours do you sleep? Predictive validity, scores on the measure should predict some type of behavior or outcome. So the scores should predict sleep patterns, for instance, on our sleep measure. So if you get a 27 out of a 30 on our sleep measure, and that indicates high rates of insomnia, then it should be able to predict a person's sleep patterns. So if a person gets a 27 out of 30, we can say, your score reflects high rates of insomnia. And the person will say, yep, I have pretty poor sleep habits, and I have difficulty falling asleep, waking up, and I wake up several times throughout the night. And they would agree they had insomnia. Concurrent validity definition is scores on a measure are related to the criterion measured at the same time. So in other words, the sleep score is related to the actual current sleep behaviors. So in other words, if you can't sleep at night at all and you're waking up too much, then you should have high insomnia scores. However, if you're sleeping through the night perfectly fine and you're sleeping like a baby, then you should have low insomnia scores. So those scores should be reflective of a person's actual sleep behavior, in this case, in real time. Convergent validity is when we're looking at scores on two different measures, that a score on measure 1 is related to the questions and some of the constructs on measure 2. So let's say we had sleep survey 1 and it says, how many restful hours do you sleep at night? And sleep survey 2 says something like, how many hours a night are restful? So you can see that they're asking fairly the same question about the same construct, and you can compare measures against each other for convergent validity. Now, discriminant validity is the opposite of that. The scores on the measure are not related to other measures that are different. So sleep, for instance, is not the same as dreaming. So a sleep survey should not have questions about dreaming. So how many dreams do you recall each night? That is a question that should not be on a sleep survey. And if it's not on a sleep survey, then that's great because you've met discriminant validity. Now, we do know that participants are always aware of being measured. They're always trying to figure out, what is this question's about? What is the researcher trying to do? And that is what we call reactivity of a measure. When a participant is being aware of a measure and therefore they change their own behaviors. So we're not really measuring their behavior, but we're measuring sometimes their reactivity. We're not measuring their behavior, we're measuring their reactivity to the questions about the behavior that are on the measure. So we always have to keep that into consideration when we're assessing people. We know that we're not always getting an actual true score, again, back to that true ability, true score about whatever behavior it is that we're interested in finding because of the potential reactivity. We're likely measuring their behavior in terms of their level of reactivity to the questions that they're being asked. Now, scale of measurement, you're going to need to know these very well, and this should be a review from your statistics classes. So we have different ways of understanding statistics of measures, and we need to know and understand these as well. When you have nominal data, also known as categorical data, this is a description of this is you have categories with no numeric scales. In other words, nominal data or categorical data is not based on number, but based on the category that you fit into. For instance, like gender, or hair color, or even ethnicity. So if we were to do hair color, a person might either have blonde hair, brunette hair, black hair, white hair, green hair, red tints, whatever it might be, but your hair at that given present time is going to go into a specific category, and that category only. Same thing with eye color. You either have green eyes, hazel eyes, brown eyes, black eyes, right? There's different color tones within there, but that's what we mean by it's nominal data or categorical data. Your eye color, for instance, has to fit into a specific category. It only fits into that category, and that's used to describe an individual. We also have ordinal data. Ordinal data is a lot of times these rank orders that you might see. Likert scales on a scale of 1 to 10, a happiness scale. On a scale of 1 to 5, what are your stress levels? On a scale of 1 to 7, what is your motivation levels? These are ordinal scales, also known as Likert scales, where we're asking someone to rate how they feel and to maybe rank order how they're feeling from low happiness to 10, high happiness on how they feel. Typically, the numeric values are limited. Scale of 1 to 5, scale of 1 to 7, scale of 1 to 10. Numerical values are somewhat limited. Interval ratings, when we have numerical properties that are literal and there's equal intervals between each value, sort of like temperature in degrees. We know what it feels like when it is 70 degrees outside versus what I'm not looking forward to this summer or the rest of this summer, what it feels like when it's 100 degrees. We know that what it feels like, there's a discrete difference in interval, feeling, even sentiment when it relates to temperature as it relates to degrees. There's a difference between 70 and 80, and there's a difference between 80 and 90 to 100, etc. And we can feel those differences in heat and temperature at specific intervals. Ratio data is sort of like looking at a ratio between two different variables, height and weight. If you did statistics with me, you might have done some ratio data. We've converted those to z-scores, but like height to weight ratios, wrist circumference to weight ratios. We did some of that when we looked at z-scores as well. Importance of measurement scales. Now, what I would like for you to do, because although we have a description here, it's very difficult in this context to describe that. So I've selected a video for you to watch. So please click this video and make sure that you view it and watch it. It's under 3 minutes long, but it gives you a little bit more detail about those different measurements of scale, nominal, ordinal, interval, and ratio scale. You're going to need to understand that because you're going to need to understand whether your variables are nominal variables or ordinal variables, because you need to set them up and tell SPSS the measure of your scales in your data so that SPSS can run the test statistics. So the rating scale provides us with quantitative information about the variables. We know that the scale, again, determines the type of test statistic, as I just said, you're going to run and how to analyze those results. Depending on the measurement of the scale, you'll know what type of test statistics you can or cannot run. If you only have categorical data, for instance, you cannot run ANOVAs, you cannot run a t-test, you cannot run correlations, but you can run a special type of regression. So your measurement of scales are also important because they help you to make conclusions about the meaning of the scores of the variable depending on the type of scale used. And down here we just have a nice example of that. So for instance, maybe you're interested in looking at the biological sex differences, and we saying biological sex, female or male, biological sex differences in social media use. In here, your biological sex is considered a nominal or categorical data because your biological sex, you're typically born female or you're born male biologically. Now, of course, there is a very small percentage of people who are intersex, who have both male and female sexual characteristics. But in this case, we are only looking at biological sex in terms of male or female. And this is nominal or categorical data because most people are typically either identified as female biologically sexed or male biologically sexed. And the differences in social media use, and maybe you asked them, how often do you use social media? How many hours a week do you use social media? How many social media platforms do you use? And from that, you get a total score, and then you're on a scale score. You have an ordinal rank, right? And so that would be how, just as a very brief example about what you might be looking at in your research studies and how some of these variables that you're looking at can be categorical and how some other variables like social media use can be ordinal or scaled data. So make sure you watch that video. And with that, we are done with our Chapter 5 measurement concepts.